here. Beautiful. Beautiful. Okay. So, this is obviously out.
And technically, that goes with 3 and 11 too.
Good, good. So my question now is, let's answer Pat's question. I guess that's my answer. Let's answer your question. As often, we create more questions instead of answering something. But I think we can actually answer this one. What's the chance of snake eyes? 1 out of what? Out of what? Over 12? So the question is, how many outcomes are there if you throw a pair of dice? How many different outcomes are there if you throw a pair? Alan?
36.
Alan's got over 36. A second? 36. Where'd you get 36 from?
6 times 6.
He says 6 times 6. He's using the last project. But perfect. Think about it. If you throw, this is why I had you have 2 colored dice. Suppose your green one gets thrown and it shows up 1. Okay? Well, one outcome could be 1 and 1. Snake eyes. The other outcome could be 1 and 2, 1 and 3, 1 and 4, 1 and 5, or 1 and 6. That's 6 outcomes right there. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. But that's assuming this one fell at a 1. What if this one falls on a 2? There's 6 more. And what if it falls on a 3?
6.
And what if it falls on a 4?
6.
And 5? And 6. So it's 36 total outcomes. This one can fall any of 6 ways. This one can fall any of 6 ways. This is one of those beautiful things where you can actually, it's the same as the 1 die distribution, except now there's 2 dice in sequence. That was the whole point of your last project. When that happens, you can multiply the outcomes. So there's 36 total outcomes. Make sense? How many of them are snake eyes? Just the 1, right? Just the 1. It has to fall 1 on the yellow die and 1 on the green die, which happens 1 in 36 times, on average over time. That doesn't mean you can't roll snake eyes 5 times in a row. It just means you probably won't. And if you do, what do?
It's loaded dice.
You take a look at the dice. If you roll snake eyes 5 times in a row, what would the chance of that be? Rolling snake eyes 5 times in a row. I'm prepping you for next week. Good. David's looking in the right place. Look at that 136.
Yeah, whatever 5 times 36 is.
It's even worse than that. It's 136th. Think 2 to the 5th power. I'm tying this back to your last project. 136. Oh, it's pretty crappy. It's 136 to the 5th power, which is essentially 0. Essentially 0, right?
It's like 7. It's like 0.7 zeros and a 1.
It's a 1 in 10 billion chance. So think about that a different way. It's a 1 in 10. Thank you for the number, David. It's a 1 in 10 billion chance. That's like someone in Russia saying, I'm going to randomly select someone on Earth, and then picking you. But it's even worse than that, because there's only 7 billion people on Earth, not 10 billion. You see what I'm getting at, friends? So it shouldn't happen. So if it does, you question the dice. Does that make sense? Okay, fair? Good? Maybe-ish. Okay. How about 3? Let's try to fill this chart out before we take our break. I hear about 4. Give me to me. Everybody, make 3 on your dice. Make a sum of 3 on your dice. Make a sum of 3. Yeah, not the number. You can't use 3, obviously, because you can't roll a 0. Very good, Cassidy. But this goes back to Nick's question, though. If we change the numbers on the dice, we can make anything we want. Let's keep these. So make a sum of 3.
Maybe there's 2. Actually.
Nick's got to vote for 2?
Yeah.
So once you've made a sum of 3, make it a different way. So right now, this is why I had you use 2 different colored dice. Because right now, I made yellow 1 and blue 2. That's green. Yeah. Yellow 1 and green. Yellow 1 and green 2. I can also make yellow 2 and green 1.
So it's 2.
And that is 2 that's 2 different outcomes, isn't it?
Yes.
Okay, can we do it any other way?
No.
That's it, correct? That's it. So there's only 2 ways out of 36 to make a sum of 3. Now some of you might be thinking, wait a minute, Rule, you bastard. Why didn't you do the little switchy thing with the snake eyes?
There's only 1.
Because you can't do the switchy thing with the snake eyes. Think about it. The only way you can have a different roll is if you actually move the dice around and have different faces facing upward. With snake eyes, you can't ever have different faces facing upward. It has to be those 2, and only those 2. Is that fair? So now it looks like 3 is twice as likely as 2. Now that was tricky to see with your guys' experimental results because there were just about the same number of 3s as 2s that you guys rolled. But that doesn't prove or disprove anything. That just means we didn't roll enough. We have to, that's what Excel's doing right now for us. It's rolling and rolling and rolling and rolling. Is that fair? We'll come back to that after the break. Let it roll for a while. It's just paused right now, unfortunately. It's going, but I can't see the results. 4! Make 4!
3.
I have vote for 2 and 2.
3. I got 3.
No. No, 3. I'm just making it myself. 2 and 2.
3 and 1.
3 and 1. And 1 and 3. 3 ways. We're going up by 1 each time. Does that make sense? Good. Remember how we only count the 2 and 2 one time. Same as snake eyes. Doubles only get counted once because you can't do them differently than once. It's just 2 and 2 and that's it. Fair? In craps, that's called that sum the hard way. So 4 the hard way would be you'd have to roll 2 and 2. It's harder to roll that than it is to just roll a sum of 3. And that's why it pays more when you do. The problem is it doesn't pay enough to cover the times you don't, which is why craps is a wonderful game for Vegas. All right, how about 5s?
3 and 2. 3.
You're starting to see a pattern, aren't you?
Yes.
You're starting to see a pattern. It's 1 and 4, 4 and 1. It's going up by 1 each time. We're picking up 1 result each time. Everybody catching that little pattern? 1 and 4, 4 and 1, 2 and 3, 3 and 2. And that's it. There's no other ways to do it. 4 in 36. Veronica, we're getting very close to what you and Claire mentioned over there, which was so freaking cool. Good, good, good. 6s.
Well,
Go ahead, count them out. Make them. Make them with your dice. Make 6s.
3 and 3 is just a
Yeah, I
1.
can't use that one. So double 3. I got double 3s.
4, 5, 1, 5.
You guys got 5?
5.
Just
2 and 4. So 4 and 2.
Right.
Double 3s. 1 and 5.
1 and 4.
And 5 and 1. 1 and 5 and 5 and 1. So any one where the faces are different, you can count those twice because you can switch the colors. But doubles have to be counted once. So pretty much any even number is going to have an odd number in the numerator, isn't it? Because it's always going to have that +1 for the doubles. So it's going to be, that's going to make a little mathematical pattern right there. So you're going to have 5, I don't know why I just changed colors, out of 36. Go back to green. There we go. That's red. There's orange. There it is. Thank you, Anthony.
6.
Random variable. Marcus going to pull out. 7. Veronica, Claire mentioned getting a bunch of 7s. Pat, I stole a look at your little dot plot you were making, the little tally chart. You had a spike at 7 and then everything else spread out. How many ways can you roll 7?
6.
6. Pretty much any combination of 1, 6, 6, 1, 5, 2, 2, 5, 3, 4, 4, 3. No doubles. Can't get a double unless you have 3.5 dice. But you don't. Not in front of you anyway.
This is the point where it gets really interesting.
This is the point where it gets really interesting, Nick. Now, good. Now what happens when you have to roll an 8?
It gets lower.
It starts going back down. You can still get doubles, double 4s. But no longer can you use all the sums. For example, you can't do 6 and 3. That's too big. That gets you a 9. You're out here now. So you can go 6 and 2, 2 and 6,
4 and 4.
4 and 4, we counted that one, right? 5 and 3,
3 and 5.
or 3 and 5. You can't use 1. I mean, 1 plus 7 would be appealing, but there's no 7. So you're stuck with 5 outcomes for 8. Does that make sense?
Yeah.
You guys buying that? How about 9?
4.
I'll go back down to 4 now. And if you don't believe us, I encourage you not to. You can just work through the dice. 3 and 6, 6 and 3, 5 and 4,
4 and 5.
and 4 and 5. That's it. Those are the ways to get 9. You can't get 1 plus anything, or even 2 plus anything. You're losing the 1s and the 2s. Those are too small to generate what you need. So now we're up to 4 and 36. 10
3.
is going to be 3. You can get 5 and 5, 6, 4, 4, 6. That's it. 2 and 36, yes? And finally, Pat, you mentioned this about 5 minutes ago, that boxcars has the same number of ways as snake eyes to get. 1, double 6s. And as a quick check to make sure we did our math right, or at least if we screwed up uniformly, add them all up. Summation of those probabilities should be 1 if we did it right. So let's see. 3 is 6, 10, 15. This is 15 down here, that's 36.
That's 100%.
Out of 36, that's 100%. Perfect. Now, let's take 5. Let's take 5. I want to come back, I want to average this, even though it seems kind of dumb to average it because we know what the average is going to be already. You and Claire nailed it 5 minutes ago before you even had the distribution in front of you. But I also like the standard deviation. I want to get standard deviation and chit chat about that a little bit in this distribution, because that actually will tell us something as far as outliers. I think we have some outliers existing here, and I want to chit chat about them and their implication in gambling. So, take 5, yes? We'll let Excel run a little bit more. It's looking good over here. Oh yeah, it's looking damn good. It's actually, well, I'm not saying too much. We'll let you guys see when you come back. Cool? Take 5, take 5. Vivica, you had a question earlier. I want to get it answered.